I hope this is working, because this has been a while since it's been a while since I got everything to work last properly. Right. Just gonna wait to see if anyone else is gonna join us, and then we'll get started. Let's get this open up and loaded. Cool. Right. So, planned for this stream. If we go to my model, and this is obviously that's the old model. This is the new DDR, mini DDR cab model, and what I want to do basically today is to get the back panel figured out, because at the moment it's just, well, blank, and these aren't final positions for either the computer or the I/O board, it's just there. So the back panel at the minute is just a blank piece of wood, and that's no good. We need an I/O panel, we need audio out, audio in, we need HDMI, USB, power, and yes. Oh, too loud on the background music? Cool. Hopefully that's a bit better. Yeah, I decided to end up using this a completely different audio player for the background music, which is far easier to deal with. Right. But anyway, yes, I wanted to get the back panel all sorted out, and let's see if I can get this to work. Right. Oh, no, almost there, but not quite. Come on, camera, why are you not working for me today? We might not be able to have a second screen today, which is slightly annoying. Right. Will you let me have a second camera, please? No, it does not want to let me have that other camera today, which is irritating. Well, okay. I'll just show it up on the top camera. So originally I was thinking of using this I/O panel, and this is a I/O panel from, I think it's a HP machine. Yeah, it's got a HP part number, but it's got 3 USBs, it's got audio in, audio out, and it's got an SD card slot, and the only thing it's missing is basically DC power and a power button, and HDMI or some kind of video output. And I wanted to use this because this would make a really simple job. The problem is the SD card section on it is way too deep. I can't remember what it is off the top of my head, so I'll just get this on there. Give or take 60 mil from the back face of it here to the back of this connector, which is going to be the limiting factor. And this is annoying me because, like I said, it would have been really nice and convenient, but if we go to our model and we just hide the back panel, you'll notice that if we go from the back of the speaker to the back of here, we have 53mm, so this just doesn't fit. It only fits if I remove the SD card slot, and that's fine because I could just use the USB on the back of it, but then I'm like, I feel like I could do a bit of a better design all in general. So that's kind of what I want to do. I want to see if I can design a better I/O panel at the back, because I kind of know my requirements now, and I need it to fit all within this space in a way that's going to be easy to manage. So it needs to fit height wise and depth wise. So probably what's the best thing to do is to just talk about the power requirements, and And let's just go over what we've got here. We've got an LCD, we've got an Intel NUC PC of some description, an I/O board, power amplifier, some tweeters in the header. I think those are 286 bulbs in there now, so they use about like 150, 200 milliamps of power, but there's 4 of them. The 2 subwoofers at the front here, these are quite powerful. I can't remember what they are, but there's something, I think they're like something like 15 watt or 20 watt or something silly. And then you've got the 2 drivers. Now all in total, if I'm going to take the theoretical maximum that this cabinet can draw, it's something in excess of 120 watts. I think 150 watts is the theoretical maximum that this can draw at any given time. Now it's very unlikely that it's going to draw 150 or plus watts at any given time, especially because the speaker output is never going to be maxed. It's going to be varying depending on what you're using. But even then, at a base level, you're already talking quite a lot of power. So part of the requirement of this cab is that the entire thing must be run from all within the cab if possible. So I would like to put an internal PSU, but it's just not going to happen. It's just not going to fit in there because the space requirements down in this base section is just too little. Oh hi Stu. I won't tell your boss that you're working. Oh sorry, that you're watching this. Yeah, just to catch up, we're just trying to figure out how to do the back panel of the cabinet. Really quick. I was going to use a HP part like this, but it's not. It's too deep. The back panel and this I/O connector is 60mm. The cab is only about 58mm when you measure it from the back of the subwoofer to the back of the cabinet, or where the back panel is going to go. But yeah, power. So the NUC is rated for quite a lot of power, theoretical maximum, and I'm not going to be using all of the power of the NUC. I'm not going to be trying to even get close to the full power of the NUC. So I know I can skimp a little off the power requirements of the NUC. The amplifier section, however, is something like 40-50 watts potentially. So, and then you've got the lights. So you'll have some kind of lights around the subwoofers because the original cab has these subwoofer neon rings. However, I think the biggest draw of anything will be these top marquee lights when they're running, because like I said, those are actual light bulbs, so those are going to be drawing potentially about, I don't know, let's say 500, 750, yeah, let's say 500 milliamps with them all on. So not a ton of power, but not a lot. But the amplifier for the speakers and this NUC is going to be the worst. Like, they're going to draw the most amount of power. So I'm figuring that 120 watts of total power, if I aim for that, it should be enough. Obviously I'm going to measure it before I'm done, but there's already a big requirement for 120 watt power adapter. Well, I need a 120 watt power supply, and it needs to be 12 volt just to make everything else easy on the inside. The NUC is rated for 19 volt at like 3.42 amps, but I don't need to run it at 19 volts. I can run it at 12 volts, and I don't have to run it at 3 amps because I've definitely run it at less, and it's worked. It's not great, but it does work. So, what's nice is that they do make 120 watt 12 volt power supplies, and those are readily available and off the shelf, so I'd rather use one of those because that saves a lot of headache. It's a massive brick, it's something like that big, but it's nice. So yeah, this cab has to have a power connector capable of taking 120 watts. We have to be capable of switching it on and off, and it's got to be something that's easy, like convenient for me to lug around. So I think this is where I'm going to transition to KiCad. So I'm looking at using a CUI, I don't know if it's PD like power delivery or power DIN or something like that, but I'm using a CUI PD 40 connector. This is your typical DIN connector with 4 power pins that are the really chunky pins, and I want to use that because the official stance is that it can take about 7.5 amps total for the connector. However, the 120 watt power supplies that I've seen, so 12 volt 10 amps, those support they come with this connector. So you know, if a standard power supply is using that connector, I'm going to use that in my board. So we've got that's our power connector, and the other things that we have to consider, because we want to basically remake that but in a more friendly form factor for the cab, I'd want 3 USBs, 2 for 2 dance pads and 1 for, you know, I don't know, a mouse or something like that. And then we've got 2 audio connectors. I would like to add HDMI as well, but we'll see how we get on. And then there's this 26 pin connector, and I'll get onto that a little later because we've been rambling for quite a while. I'm just going to check. Yeah, not quite, Flibble. First of all, thank you very much for the compliment there. And secondly, no, the I/O board here, it kind of does support the pad, but it's basically only in the sense that it has up, down, left, right for each player, and then about three or four inputs for the control panel. The main reason I have this I/O board is that it controls all of the lights. It handles conversion of inputs to USB, and then it also would allow me to transition the entire cab to run a real arcade board. So if I wanted to connect to 573 or Python 2 or, you know, Bemani PC, Dragon, whatever, that board should theoretically let me do that. Good point with the Pico PSU, Garo. The problem is, well, it's not actually a problem because everything off here runs from 12 volt. So the I/O board takes 12 volt input for the 12 volt lamps, because the 286 lamps at the top are 12 volt. The neon rings will be 12 volt, the NUC is 12 volt, everything's 12 volt on the inside. So it's not a problem of the power supply not fitting in the cab. It's still a problem of I have to get like 120 watts into the cab. But it's more a problem of I need to get an I/O panel going. So yeah, that's kind of the requirements. And like I said, to support running external arcade boards, I have to have a secondary connector 26 pin. And I remember having a chat with my friend Stu, and he did suggest USB-C. Unfortunately, that's just way too complicated, so we're not going to do that. Anyway, problem I have. This is the currently the I/O. Ignore the PCB over here because I kind of don't know what I'm going to do with this. We'll go into that a bit later. But if we just take a measurement from the bottom here to the top up here, we have 117 millimeters. So one thing I haven't actually checked is whether or not that will actually, as is, fit in the cab. And it will just barely fit in the cab. So that's given me, that's 6 mil of, that's not enough, that's 6 mil of spacing. Yeah, again, USB-C 120 watt, it's not a problem of the power supply. Yeah, I can get a standard power supply. I'm not worried about that. I'm worried about making the I/O panel at the back, because the real life cab, which I have to the side of me to be honest with you, the real life cab, I'm getting to the point where I actually need to figure out where stuff is going. Like, where am I putting in the audio amplifier? Where am I putting this I/O panel? How am I attaching it? That's the thing I need to figure out. Because if I need to get something 3D printed or I need to get PCBs made, I need to know that now. So yeah, I'm not worried about how to power the cab. That I've pretty much solved. It's how do I put everything in the base cabinet if I can, and do I need to start using the monitor section more for, like, do I put the I/O board in there, for example? Because I might have to put a fan in here too, because it might get too warm in there because of the NUC and the power amplifier. So yeah, really want to figure out how I'm doing these boards, or at least how I'm going to fit them in there, and what design considerations I'm going to have to make because of it. And like I said, at the moment I want to get the I/O panel, because once I have the I/O panel, then I can figure out where I'm going to put it, and I'm probably going to put it in this corner over here. And then it's just figuring out how do I connect it up to everything, because this original HP part had multiple different USB cables, which I was going to connect into one of those USB expansion boards, like the ones that have the pin headers on them, and I was going to connect this up to the audio amplifier, but there's too much cable there. I need something thinner and more streamlined to fit inside the cab. So that's where we're at. That's why we're doing this. That's why I need to do this now, because what I design is going to really make a difference later on. So let's get started, shall we? So what I'm tempting on doing is starting a new PCB, because what the rebar is, and it's a terrible name, you don't need to tell me, but it's a terrible name. The original purpose of the rebar was to take the either DC power input, whether it be through 2.5mm jack, or it was I think it's a JST PH connector. That was originally supposed to sense whether or not the PC was turned on, or whether or not the amplifier was requested to turn on, and then this relay would be the main relay which would turn on the rest of the cab. And the reason we have that is so that we're not drawing power all the time. When the PC is off and in standby, the rest of the cab is off, so you could just leave it plugged in all the time. But this isn't going to work. This whole board is not rated for 120 watts power. Also, I don't know if I like GST PH connectors, because I think they're too weedy. I think they support like 1 amp of current per contact, but I don't know, it just seems a bit questionable. So that's going to be redesigned. But like I said, more importantly, I need the I/O panel done. So what I'm going to do, I'm going to go back to the schematic. I'm going to copy these. Copy those. We're going to close down rebar. Just save just in case something goes wrong. Right, and let's make a new project. I'm going to take that off screen so don't see everything. So we're going to go and save this under my SODDR folder. Oh, by the way, if anyone sees like SODDR, SODDR, that's just the sort of internal code name I've been using for ages. So it's kind of a terrible code name, really. It only makes sense if you know computers because of SODIMM. But right, where are we at? Let's go KiCad. Let's go into SODDR, and we'll make a new project called... Anyone got any funny names for an I/O panel? I mean, I've got the Lion board, I had the rebar, I don't know what I'm going to call my amplifier, but... Right, I'm just going to call it I/O panel for now, and be boring. Let's open the schematic, paste. Right, so that's the I/O parts. Oh, and I've noticed a little glitch. I don't know if it'll do it this stream, but if my screen here freezes at any point, please let me know and I'll refresh it. I noticed that when I was doing my test streams. Right, so because I've already assigned the footprints, I should be able to annotate this update PCB, and there they are. One thing you might be able to tell from this, maybe you can't, all of these parts are vertical parts, so they'll point up from the base of the PCB. I figure that's going to make it easy, because then all I have to do, we have a PCB board and all the parts are sticking out right angle to it. All I'm going to need is some standoffs, and they can just screw it onto the cabinet or the back panel. And that's another thing, we're going to have to worry about the heights of all these connectors, because the PD40 connector is slightly shorter than the audio connectors, and the USB connectors might be shorter than them. So that's going to be fun. Also, we're going to have to design ourselves a right angle HDMI plug, because apparently KiCad doesn't come with one. You know, I think I've got so many DDR boards, like so many 573 now, 573 boards now. It's kind of ridiculous. Like I thought I'd never get one for ages, and then just within the space of a couple of months, 3 have just appeared. Right. Right. Hold on just 2 seconds. Right, sorry about that. So, Gary, you make an interesting point. Panel mount breakouts, I might do that for HDMI. Do I have the NUC around? Yes, I do. So this is the NUC that I wanted to use, but I think it's going to be too thick to use. But what's nice about it is it does have 2 HDMI output ports on it. What's not nice about it is it doesn't have any audio out, so I have to use either HDMI audio extractors or USB. It's meh. But what would be nice is to be able to hook one of those HDMIs up into the internal monitor, and then have the external port to connect up to, you know, a projector, an external monitor, what have you. But yeah, I think what I'm going to do is end up using the panel mount HDMI connector, because it's probably going to make more sense. But if we could have it all in one big thing, that would be great. Right, so I'm waffling more because I'm kind of procrastinating from doing this. So let's get a theoretical size of how big we can make this. So I think these internal blocks of wood or pine strip are 15 by 15, and then the cab itself is 183 on the inside. I don't think I want it to be any bigger than I don't think I want it to be any taller than these 2 points, so 153. So let's say our I/O panel cannot go above 150mm. That means it will definitely fit in whatever piece of back panel, like wood or plastic insert. And let's try to make it, I don't know, how wide is this to here? 100. 150 by 50 sounds about reasonable for an I/O panel. Because the power button for the NUC is probably going to be over here, maybe. And again, that gets into another problem that I'll mention in a minute. So let's go set our grid to 1mm, which it is. Let's get the edge drawings. edge cuts, and we'll draw a 150 by 150. Alright, let's go down here, do 150. Yeah, so I think that's a modest amount of space for a back panel. You know what, let's get our copper filled regions up, because I like doing that. Yeah, we don't have a net, so let's get a ground connector. In fact, we'll get our power connectors. We need 12 volt. No, that's a diode. 12 volt. Let's get 5 volt. We'll need 12E. No, will we need 12EA? No, we won't. In fact, in all honesty, I'm not sure we'll need 5 volt, but we'll see. So that should, if we now annotate our board, that should give us the ground lines that we, the ground planes that we need. No, it does not. Okay, well, we'll just do ground, see what happens. No, okay. Well, I'm looking real pro at this at the moment. To be fair, Garrett, KiCad's really quite good. Once you get used to how it works, it's actually pretty intuitive. Right. I need to find a pinout of a power supply I want to use, because I think what I'll need to do is connect these up to, you know, power connectors. Sorry, connect them up to the power lines. So let's get a new tab open, shall we? 120 watt, 12 volt PSU. DigiKey could do that. Yeah, let's have a look at this. Right, AC to DC wall adapters. Does it give us an ability to select? Right, we want 12 volt. 12 volt, and we need power. We'll go watts, a minimum of 120. It doesn't let me choose the end of it. That's kind of annoying. Is there a big delay in chat? To be honest with you, if it's because I'm not responding fast, it's because I'm too engrossed in this, and so I don't keep checking up on the chat all that often. So I apologise if that's the case. I'll try to keep on top of it. Right. 12 amps, 150 watt. Oh, good lord, the prices. Okay, let's see. What's this one? Okay, that just comes out into a jack connector. Can a 2.5mm DC barrel jack support 120 amps? So 120 amps, 120 watts? That seems quite excessive for that. Yeah, so I have just seen your message. It does come up for me saying that you sent it at 7:14. I don't know if I can sort that, if it's bad. Problem is, YouTube is terrible with streaming in that sense. It doesn't really give you a very fast response time. Sorry, what I mean by that is, like, obviously Twitch is designed for streaming and pretty much getting the message to the streamer very quick, but YouTube seems to be more about delivery than it does, you know, being tailored towards streaming. Okay, so is this a mini DIN? Yeah, there you go. DIN plug, 4-pin. There we go. So there's our polarity. And I think that's quite a standard polarity. So our top 2 pins are 12 volt. Alright, so let's see, can I please do my annotation now? Oh, my annotation, yeah, there we go, let's go. Put this on the bottom and top layers. Priority is 0 because, yeah, so anything else needs to be priority 1, 2, 3 and up. Thermal release, will put the gap down because whoever set 0.5 mil is silly. Cool. Let's go. Right, so do B. Let's get our power connector. Let's get our power connector on here. And that should give us a nice filled zone. Yeah, those spokes are tiny. So we would need to increase that. But we want our minimum to cover enough. Well, that's the point. How are we going to connect these up? Because we can need to connect this board, the I/O panel, to whatever's going to control the power distribution. We need to connect the HDMI to a HDMI socket. Let's just say that's a panel connector for now. We need the USBs to do something, and then the audio connectors to do something. So I wonder if we should, rather than having any kind of active electronics, we're just using this to space out the connectors that we need. Also, here's the thing as well. I don't have a PD40 connector, I don't have the audio connectors, and I don't have right angle USB ports, so this is all theoretical right now. Alright. Let's just put these down here. In fact, we'll put the audio higher up to keep it out of the way of any interference from the power supply. Okay, put the USBs below that. And then let's put a theoretical HDMI down here. And yes, that's a right angle plug, I need to change that. So put this PD connector in line with all the USB connectors, like so. And then that already gives us quite a nice layout. So I should probably explain why I'm using a big HDI, or what is it called? I can't remember. It's a something connector, an MDR connector by 3M. So I want to use this cab on real arcade boards, real System 573s, to play my actual DDR games using a real cab. And that uses a standard called jammer. Now jammer is correct me if I'm wrong, it's a 52-pin edge connector that contains your power, it contains your audio, contains video and your inputs. And so the easiest way to connect it up to the cab would be to take those raw signals and put it through a custom connector into the relevant parts. but I don't want to put a big 50 pin connector in the back. So what I'm also using is want to use is called a serializer, which allows me to convert the cab. So let's go back to the thing. So part of this board, you might notice down here there's a couple of holes. One is for USB-B and one's for USB-A, and those I want to use for JVS connectors. JVS is not USB based, it's actually RS422 based, but long story short, it was introduced as Jammer 2 and it was designed to replace the original 56 or 52 pin connector. That, and the way they did that is they took all the inputs and put them onto an I/O board, serialized them, put them over standard PC cables because it made it cheap to implement. And then so your arcade board, your JVS arcade board, would be using a serial bus connection to the I/O board to just minimize all the wires. And so I'm using a JVS. So this board is doing double duty. It'll act as a USB controller for the internal PC, but then you flip one of these dip switches and it'll turn into a JVS board for running JVS games. So long story short, this connector here will have VGA or RGB in sync, raw like line level audio and JVS connectors, and like a few tiny signaling things to say to the cab to turn on over this connector. And then the idea is to plug in, if you're going to use a real arcade board, the serializer will also have a PD40 connector that you would use to power the cab. So you're powering it all off two cables basically. I think that's about the simplest way I could do it and make it still feasible. But yeah, we need this connector, absolutely. We need I want the audio connectors, we need the USB, and ideally HDMI, but again, that could go onto a panel. Right. So that's, I mean, that's quite, if that's real life sized, if that's sized to accordingly, that's 150mm by 150mm, which is I think what we set up in here, wasn't it? 150mm. Yeah, 150mm. So we could put that connector up here if we wanted it to keep that nice consistent look, but we wouldn't have to. That's nice to know. So then the question is this just a breakout board? As in, does it have any active electronics? Do I put in like a USB hub here? Or does this just combine them into one cable? Because the beauty of the original HP panel was that it was all cables at the end of it, so I could theoretically cut these down and then, you know, they're already at a right angle. But because I don't really need, and I don't need the SD card slot, so that's why we're not adding one here. Right, so how do we want to do this? Oh, and here's another complication. I want to be able to, when you plug in a 3.5mm audio jack into the audio input, I want it to turn on the cab. The problem is that most standard audio connectors are like this. They have tip, ring and sleeve, and then they have switch contacts on tip and ring. So that allows you to have, you know, if you have no audio source connected, or sorry, no connector connected, it goes off into your internal speakers. But if you have something connected, it disables the internal speakers, and then all the audio goes out into the external device. And so we need to be able to do that, but we also need to be able to turn on the cab. So how do we get something that's only supposed to switch audio to turn on the cab? And I'm not sure how to do that, because like, so our audio would have stereo output, so we need ground left and right, and even though we're not we're not worrying about whether or not there's something going into so basically there's no audio connecting to RN and TN, but we can't really use them for switching. So right, I'm just not sure how to do that, in all honesty. Nothing springs to mind. Right. Let's close this window down. Yeah, a relay could do it, maybe. But how do I trigger the relay? I mean, there's already going to be on the rebar or whatever power distribution PCB I'm using, there's going to be a relay or two, whatever, to carry the current. But then, like, how do I turn it on? Because about the only thing I can think of is using a non-standard connector, so that instead of it being left, right, ground, it's left, right, ground. But so you're using a sleeve for what, like basically an audio channel, and then you're using the tip or the ring for switching. But I don't like that, because that means I can't just grab any old cable and use it. I would have to use a specific cable for this. Simple option number 2 is I make a custom cable that connects into the 26-pin connector, which would normally be for like external boards, but they'll have line level audio input. But that gets into problem A again, which is I'm using a proprietary connector rather than a custom one. And then I suppose the counter argument to that is you could have a little dongle that plugs into the back that allows you to use 3mm audio input, and then, you know, if the dongle's connected, the cab's turned on, you take it off, it's turned off. But then it's again another thing to carry around. And then I suppose as well, it would mean I wouldn't need this audio input, but then I don't know, it makes it less convenient. So this is going to be a rather dithering stream, where I can't decide what I want to do. I'm just trying to think of what would be the best way to go about this, so that I can just pick it up, go to a place, put it down, and I can use it forever. Take it home and, I don't know, put it on one of my non-existent shelves, and then use it as a Bluetooth audio speaker. Be completely overkill, but it would be fun. The problem is, Flibble, the I/O board isn't powered up until the PC is, or whatever it needs it is powered up. So I only need 20 pins of this custom connector for VGA audio and input for JVS. The problem is though, I only need 20 pins for that, and then the other pins are going to be ground, and then sort of they'll tell the cab what to do. They'll tell the cabs to turn on the audio, tell the cab to turn on the I/O board, for example. But the I/O board's not going to be powered up, so I can't use that. And even then, the I/O board itself is already doing a lot. It's doing double duty with being an I/O board and converting between JVS and USB. And I don't want to use it just for monitoring an audio input, and plus that means I have to add extra parts onto it, and it just gets really complicated. So I think part of me is telling me it probably would make more sense to use this as a connector and just deal with the fact that I'm going to have to do a proprietary connector, because there's not really going to be a simple way to do it otherwise, is there? You're either going to have a proprietary connector, and it'd be really stupid with the audio input connector, or you have a dongle, which is still not convenient, but at least it's kind of makes sense. You can still use standard cables. And that's the other thing as well. If I'm gonna make this, multi-IO connector, there's nothing to say I can't feed in extra things. Maybe I want to feed in, like, I don't know, let's say a PS2. Let's say I want to feed in a PS2 into this. Theoretically, I could make a connector that connects from this into the back of the cab, that goes into, a SCART connector, for example. That gives me my RGBS and my audio, and then I can use like the JVS and I can convert that, or I can just use it as whatever. So this connector can be like a multi-AV out, or multi-AV in. It can convert a lot of things to each other, and I'm only using the standard connector. The only problem is it's kind of expensive. So audio out's easy. If there's something connected to the output jack, I can make it so that it either outputs only to the output, or I can have it so that it outputs only if there is outputs the internal audio, unless there is something connected to the jack. And that's something I can easily have a dip switch, or even jumpers on the back of this PCB to control it. You know what, I'm thinking we'll put power connector at the bottom, we'll put USBs above it, we'll have the HDMI as an external screw-on mount connector, because that saves me having to wire up a HDMI cable. We'll ditch the IO connector, sorry, the audio in connector, we'll just have an audio out connector. I think that's going to be the most sensible option. So let's ditch the HDMI as well, and let's just have this. So that means our IO requirements, yeah, we can comfortably fit that on the back panel. In fact, I wonder if we can. Let's just see if we can put these like down here. Will this actually fit? It will. That's kind of neat. Because also I'm going to need screw holes as well. So I'm going to need to have at least probably three. One here, one here, one here. Maybe something down here. Because I could put some LEDs as well for like power. Even though you're going to know if it's turned on or not. Yeah, let's go with this. I like this a bit more now I've seen it. Because USB is quite easy. I can just use IDC connectors, just standard ribbon cables, and then just terminate it into DuPont or into a USB cable. So now the question is, do I like it like that, or do I like it like that and have it like that? No, I don't. I like it the other way around. The thing is with mobile phone connectors, Flibble, is the way those work is they have extra sense pins in them. They have an actual third switch. I can't find I can find a vertical 3mm jack with switchover that has an extra switch, but it's not a standard part. I want to use standard parts to just make sure it's not going to rely on something I won't be able to get in a couple of years' time. So, true, it would. Well, the thing is, the connector here, I designed this to be quite well shielded. So, we'll save this. We'll go to KiCads. Let's go and open up. Just so I can catch everyone up. Where is it? DDR serializer. Okay, let's try to find that. Alright, let me just quickly find the serializer. I don't know why it's disappeared. Where are you? So DDR serializer project. Okay. So. Okay, this isn't complete, but this is kind of what the serializer is. It connects to the Jammer connector of the 573, connects to the cabinet light outputs. It emulates 2-stage I/O boards, so you can connect it up, and you can run legitimate game like software. You don't need no I/O patched things. Even has a joypad connector for PS1 pad, because you know I might actually use it myself for other reasons. But it has VGA out, has a DC barrel, well, DIN DC, JVS, and then here's your 26-pin HDR. No, what was it? Something connector. But yeah, the actual pinout of this is quite good, I think. So it does share power, but every other pin that's analog is grounded, so it should be relatively isolated. Like over here, you got a ton of grounds, ground, audio, ground, right, and then I'll put another audio ground over here as well. So that makes it really nicely shielded on the PCB and in the cable. Right, see you later, Stu. So, right, anyway, that's the plan. So that's going to be a nicely shielded connector. Hopefully it won't have too much noise. Let's get the I/O panel open up again. Right. You know, I should have copied... Yeah, look. God, I am all over the place today. I should have copied the pinout from this schematic, because I want it to be a 1-to-1. Right, there you go. So we've got our pinout of the connector, 3M MDR, 3M MDR. Oh, what's that? DigiKey. Let's have a look at that part you've just sent to me. Flibble. That's not right angle. That's sorry, that is right angle. It's not vertical. And it, yeah. Good for phones, but not good for in my case, unfortunately. Thank you for the suggestion, though. Right. Oh yeah, we're gonna need to. We need another connector because we'll need RGB going off to the LCD. Which has just occurred to me. The LCD doesn't actually support 15 kHz video. I'm gonna have to make it support 15 kHz video. Right. All of these USB connectors can share a common ground. Again, do I put a USB hub chip on here and then just have one USB to connect? Only downside is complexity. I don't know. Let me get some stuff put down and pretend like I'm actually doing work. Right. The V-bus connections, those can be all parallel together, can't they? Because V-bus on USB-A, it's not per port. It should be, but it's not really. So we'll connect those all together. We'll just get a tag V USB. Cool. I guess we'll just put some extra tags on for USB 1A. Actually, I should do D plus D minus. Alright. Get those down there. Let's put that into USB 2. Copy and paste. I suppose you're right, Garrow, but... Oh no, I want USB 3 here. Right, so that's our USB connectors wired up. I should probably label them as well. Oop. Also, I should really put polyfuses on this, shouldn't I? I should have also put inductors on this. Yeah, I need to do that. As if I've not over-engineered this cab enough. Right, polyfuse. There's a point. I'm not going to be charging cables off of this, connectors, but I need to cover for an amp, don't I? And I need a bit, like 20% extra. Let's see what Mauser has. I want SMD parts as well. This is kind of how I choose how I design stuff. I just go on to Mauser. Right, SMD, SMT, what's hold current, trip current, oh that's only one remaining, okay, let's get rid of that, and that, let's say, trip current being, that's not a lot. Yeah, those are... Because I'm not gonna put like any kind of smart port monitoring to it. If you short out the V-bus to ground, I need to protect the port, but I don't want to use transistors to disable anything, because I just want this to be a simple interconnect. But that doesn't look like it's a. This doesn't look like it's great. Voltage, current rating, max, trip current. Let's say 1.3. Let's go 1 amp. 1 amp should be plenty. I mean, USB 2.0 devices aren't supposed to draw more than 500 milliamps unless they specifically request it. So, and you can get these in SMD. Cool. Okay, so let's go normally stocked in and active. We want SMT. I don't. Let's go. Go that much. No, I guess the resistance is going to be too massive. Cool. There you go, USB peripherals. Brilliant. So So Imax is 40 and 100 amp. So that's when the when the polyfuse will just explode, I guess. Hold trip current. So should we say 805 L50? Alright, hold on a second. Hold current is the maximum current at which a device will pass without tripping in 20 degrees still air. So that means when it's in the cab, if it's at 20 degrees inside of the cab, which will never be 20 degrees inside of that cab, that means it can only hold half an amp with still air, because the minimum resistance and maximum resistance is nearly an ohm. Okay. So I don't want regulators. I want. Oh no, this is all PCB calculations. That's not what I want. What do I want? It's not here. Oh, that's nice. I didn't know I had color coding. Cool. So let's see. So we're going to be passing 5 volts. We're going to be passing 5 volts, and we're going to be passing it half an amp, but we're going to be putting at least half an amp through. That's the point. How hot is it going to get inside that cab? It's going to get quite warm, I'd imagine, with the NUC in there and the amplifier. So that would say like it can only do, let's say 40 degrees it gets into, which is quite hot, but I mean it's only going to be able to do 90% of the rated current. Okay, that's the reflow characteristics. Okay, that's just that. So how much power would we be drawing over? So we got 0.5 volts at 5 volts over potentially up to 0.85 ohms. That gives us 29 watts. That can't be right. Oh wait, sorry. Okay, let's do this again. So 5 volts at 0.5 amps. That's 2.5 watt. 2.5 watts into basically just under an ohm. So we would need a 75, potentially. Well, no, because let's just go. Okay, let's just pick this one. Let's just go with 750 milliamp rated fuse. That gives us plenty of overhead, especially at the thing. I can always change the value of it later on. And then we'll just connect these. We need to put these onto each USB port. I'm not going to connect up any inductors at the minute to the. I'm not going to connect any inductors up to the data lines, even though I should. Well, here's the thing, Garo. I'm gonna put, like, this cab is not, it's not cheap. Like, it's not cheap in time to make. It's not cheap in parts and, you know, electronics to make. So if I'm going to over-engineer it, I'm going to over-engineer it because I want it to last. Now, if I was selling it, now there's a different question, because I might realise very quickly, you know what, it's easier just to design the one and make many. What I will do is I'll put on some inductors, and I will do the calculations off stream because I don't know how to do calculations for inductors. That was a well-timed ending to that song. So let's just assume that we've got that all figured out. Copy and paste. And let's change that to USB 2. I mean, I think this is kind of the most complicated part I want to... the most complicated I want to make it is... You can't kill it by shorting out the USB ports. That's kind of what I'm thinking. USB 3. So that's my USB ports, that's my power, so I powered in. Again, I still need to get that amount of power off the board. There probably is, but I don't know of it. Right. You know, I'm thinking we put on a DuPont header, PC standard AC9/Intel HD audio header, and we use that. Because then I can use a standard cable if I wanted to go in from the back panel to the amplifier. Still don't know how I'm going to... Oh yeah, I said I was going to use the 26 pin connector to power it, so that's fine. So let's add... What is that? That's a 1x5. 2x5, sorry. 2x5. I should get the, what is it, Intel HD audio standard? Okay, I don't like that definition. Right, okay. Good lord. Page 219. What kind of pinout is that? Oh, this is for a chip. This isn't for the audio standard. Do you want to go out, cat? There you go. So we'll get on to, we might get onto the amplifiers a bit later. Oh come on, don't tell me this standard's not going to work. Okay, let's do it a different way then. So we'll get onto the amplifiers a bit later because I'm going a little bit overkill with the amp. But I mean, I'm not using Class D amplifiers. I'm using Class AB. Cool. I need to pin out, not. Okay, that works, I guess. Where's the text? There is. Aha, there you go. Okay, so let's open that image in a new tab. Excellent. So port 1L, 1R, pin cool. Let's go for it. I want a 2.5. Do we want horizontal or vertical? We'll do horizontal for now. We'll see how that feels later. So that would be. So pin 7 is no connect. That's not no connect. That's no connect. And then port 1 is output, port 2 is input. They label those because you can have them either direction, but typically... Oh wait, no, what am I talking about? It says right there, port 1 is microphone and port 2 is line out. Shows what I know. So, we'll just label that as our audio. Audio out jack. Because this is pretty much going to be a straight up connection to it. It's going to be... I should put inductors on this really too, shouldn't I? Yeah, I should. No kill quite like overkill. I really need to expand my audio library. Right, so... Oh, thank you for doing that. Right. Well, that's actually lined that up quite nicely, because that's like there, that's there. Then sense send. Oh, that was right. Yeah, so that was... So sense send, you need to ground sense to return to sense send in AC9 to, sorry, in HD audio to get the audio to send outwards. But I don't want that. I want to flip the audio. I think what I was going to do was have like this complicated setup where on the chip, on the amplifier, it would have an analog switch. So if it detected, if you had a HD audio panel and it detected you connected a jack, it would then use that jack and switch over. But that was only because I was using this panel, which has HD audio jack connectors. And what's kind of annoying is actually those jack connectors are almost perfect for what I need, but these are not PCB mount. So if I was to do my own panel, to make it easy, I need to do AC97. So AC97 pin out, because if I remember rightly, okay, so that's still HD audio. I mean, there's no real need for me to follow the AC97 pinout specs on this, but I want to. Okay, that's not what I need. There you go. AC97 audio, so the returns. This is what I mean. If the jack's not inserted, 5 and 6, and then 9 and 10 are bridged. That's why you have jumpers on some motherboards, so that it always works. So that makes that easy, because all I have to do is bring those down, bring them across, up and over, like so. There you go, that's my jack wired up. Audio 5V, we don't need that. We would then connect this shield, that needs to go to ground, and we'll keep the audio ground separate on this PCB, just so that we, in case we change the amplifier and it needs a isolated ground, we'll just keep it like that for all the audio stuff. I do this on the jammer connectors, even though on most PCBs they just join them together anyway. So in fact, I should probably label those A ground as well, just for consistency, and because they won't connect otherwise. Cool. Actually, I should probably put inductors on. Put an inductor on the ground as well. Because it's more designed that if something, if you're randomly connecting and disconnecting stuff, you're not going to cause any issues, you're not going to fry anything. You shouldn't, but you can never be too certain. So mic and mic bias, well, I don't care about that. It's going to be left to right audio, so we'll follow the HD audio standard for this, the input port. Yeah, so it's funny you mentioned about the one watching now, because on Twitch, if you're streaming on your own, then there's one person watching and it's yourself. So right, I should also put the inductors here as well. I should put inductors on everything, shouldn't I? God, why am I like this? Yeah, so most of the time an inductor does nothing, and I need to design these in such a way that normally they don't do anything. But if you were to hot plug something like this whole connector, it just doesn't just surge it. It's completely overkill, but I should do it. Really, these should be LCL filters. But an inductor filter will work fine for this. Oh, I should stop doing that. You know, I just realised as well I haven't assigned any footprints to these. Let's do that now before I forget. Because these need to be 080, what are they, 0806? 0805, sorry. SMD, so I need an inductor, SMD, and 0805. Cool. Copy. So that way we have all of our inductors when we need them. I'll worry about making these schematic look pretty later. Yeah, I'm going to need it on all these pins. Although some of these are technically... No, they're not going to all be ground, so I'm going to hold off that. Okay. I should put it on the... See, the thing is, I'm not going to... I am, though. I was going to say I don't need the 12 volts, but then I kind of do, because if I want to have an active accessory on the back of the port, I might want to do it that way. Welcome, Mumbo. How are you doing? You don't need that job, Garrow. Actually, best not do that. Probably not wise to cause issues with jobs. Right. Let's just save that. Let's see how that's looking. Oh, I didn't put fuses on the... I didn't put a footprint on the polyfuses. Oh wait, oh I'm a donut, I should have put that, the polyfuse should have had the 0805. Okay, where's polyfuse? Fuse 0805. Yeah, don't worry if you don't understand things, Mumbo. I pretend like I understand I know what I'm doing. So, right, let's try to update the PCB. Cool. We got a crap ton of connectors. I haven't even decided what kind of USB connectors I'm going to be using either. Like, in terms of like, because these are just the standard built-in keycad ones. So let's get this connector going like that. I don't want to put USB-C, Garrow, because it's just confusing. Plus, USB-C is kind of inconvenient because most external controllers, like if I was to just grab a you know, if I was just to grab standard old pad, it's more than likely going to have USB-A on the end of it if it's a wired one. And most dance pads, for example, will come with a USB-A on the end of it. No, we're not doing proprietary Mini V. This is these are host ports, they're not device ports. Right. I suppose, right, let's put that on, oops. Let's put that on the back side of the PCB. I suppose we could put all those inductors on the back side of the PC, because all of this is through hole, so yeah, let's put it all on the back side. Because it doesn't matter about which side gets loaded up, because all the SMD stuff I'd probably get the manufacturer to do. And the SMD parts can be glued in from the top. So they can be glued in so that when it goes through the reflow oven, it solders. But that's quite a nice I/O panel so far. But that is only audio. I should change this to an SMD connector. I don't like SMD that much in terms of when it's these pin headers, but I might need to on this board, because that would make it a lot easier to package. Although it's really annoying. Oh, that's vertical, that's why. I was going to say. I can't see where the pins are, but that needs to be horizontal SMD. Oh! You can't have SMD horizontal. I swear they could have sworn you could. Is that a problem? Would that be a problem? Because what did we say? We've got 58mm of clearance at the back, so 50mm if we're counting for just random, it not fitting us. This connector is 20mm at a right angle, so 25. I should just get the cab. Right, you're going to see some other parts of this that aren't in any videos and won't be for a little while, but they're test parts, so right. I doubt the phone's going to let me use it. Nope, of course not. Why would it work? Kind of find it interesting that my phone is refusing to work on the camera. See, can you connect up? Yeah, if you could, Garo, that'd be great. Kind of getting to the point where I do need some. Right. I'm trying to see if I can get the external camera to work, but my phone is being a pain with it. And yes, it's Apple, so of course it's going to be a pain. But I'm connecting to a Mac. Why can't I connect to thing? Did I disable it on my phone? That's probably what I did. Thoroughly riveting stream of me going through my phone. If I can't get this working in the next 2 minutes, I'm not bothering. Good lord. How did you do this? How do we do this now? Like, it used to be that I could just connect my, like, I just have my phone on my Mac as a camera, and now it's just disappeared. Reconnect iPhone camera to Mac. Oh, it's not. Do I have to use a USB connector for it? Oop. That's not the thing I want to use. This seems like it's going to take a while to get working. Do I have a lightning cable with me? Nope, too much effort. It's taking too long. Right, you know what, let's just move the main camera. What could possibly go wrong? Right, so here is the back of the cabinet. In fact, let's make it a little bigger for you. Good lord, this is terrible. Excellent content. I'm sure everyone wanted to see this. Right. So, this is the back of the cabinet at the moment. It's all primed, ready to go. You will see how I've built this and got this all ready in a video, probably in the next couple of weeks. I would say no longer than 2 weeks, maybe 1 week if we're lucky. But, yeah, so let's just imagine for a moment that the back panel is going to go on like here, or around about here. So obviously the original I/O was going to go on over here, and it still kind of fits, but it wouldn't really, because I'd need plastic here, the plastic holders to connect to basically go into the wood. But for using it as an idea of how to like route cables, I definitely have a lot of space, but I couldn't put anything here. Just realised you can't quite see. There you go. And it's blurred. Let's unblur you. Right, there we go. So, also, I might be only able to fit this kind of style amplifier. Well, I'm not using this amp, I'm going to be making my own, but I think down there is about the only place I can realistically fit them. Right, so yeah, let's measure down in here. So yeah, about 60 or 55 is the clearance that we have. Oh, that's all. That's reversed. That's unfair on you. It's 54.57. cable, standard DuPont connect cable, plus the PCB plus the thickness of that. So the wood ends here. You'd have the PCB. Oh, speaker's not all the way in. So yeah, when it's in place, it'll fit. So DuPont. Okay, we can do a vertical connector. That makes it easy. Right. Let's put you back to where we were before. Oh no, you can see the mess all behind me. Ah, no you can't. Except you can, because, you know, you can't hide that mess. Right, let's put you back to where you were. Cool. So, all that faffing around just to see if vertical DuPonts will work. And they do. So let's use vertical DuPonts, SMD DuPonts even, and then we'll go from there. So we need that. What's the current rating for a DuPont? Well, actually we need one for the USB as well. Mumbo, difference between them is, so on a PCB, I don't know how well this is going to show, but if you had a PCB with a vertical connector, it comes straight up like that from the board, and a horizontal one is one that goes sort of at a right angle. So when I'm talking about a horizontal connector, I'm meaning one that pokes up from the back side of the board, so you know that's the thing, and then you have your connector on this side. That's what I'm talking about, because I couldn't use a right angle even though it would allow me to have like save on the depth of the board. So we should have at least what I'm overcomplicating things again, aren't I? Where's that USB board of mine? Thankfully I have a very long cable on my headset. Where are you? That's a good question. I can't see it anywhere. Okay, that's... Oh, I know where you are. Are you in here? Nope, that's my 573 box. I have too many boxes all about. Nope. Okay, spending too long. Let's go into eBay, shall we? Right, eBay. We want to look for USB hub internal. Oh, they do multiple ones of them. I swear I bought more than one, but I can't find either of them now. See you later, Garrow. Thank you for joining us. Can anyone read that connector part? That pin number? Pin number? seems about right. No, it's not one. Okay, let's just have a look, see if we can find one with a better picture. Oh, I can't read it because they've used horrible JPEG compression. It would be really handy if I knew where my hub went, but I can't. Oh, I know where it is. It's in here. Let's rip it out quickly, because why not? We've wasted enough time on this stream. If you're curious what this is, I don't know if I recorded, I don't know if the VOD is still on Twitch, but on Twitch I did a stream where I was messing around with this PC. It's kind of like a POS thing, but it has I think it's like for industrial automation. But it's quite a little fun thing. I was trying to see about getting Hello World written on the display. I really should want to mess around with that a bit more, but more pressing priorities. But what it does have is my little chip on the inside of it that I need at the moment. See, this is why things take so long for me to get done, because I just end up screwing around, doing things I don't really need to do. There you go, SSD. So, that's the inside of the box. It's just a mini ITX with, funnily enough, a Pico PSU. Actually, it's quite a nice little board, to be honest with you. I need to get the back panel for it. Let's get some light in here, because I can't see crap. I still can't see crap. GL850G. Is that the part number? GL850G. There we go. GL850G USB hub controller. Oh, I see, so they got multiple pins for it. Awesome. Alright, so the SOP28 is what it uses, and it supports 4 ports if I'm not mistaken. Yeah. It's got quite, oh, it's got overcurrent protection and stuff too. That's quite useful. Yeah, can we put that hub on the thing? I doubt it's got 850G on here. Nope, we'd have to add it. If I put that onto the PCB, that means I only have to connect it with one USB cable. I'm going to have a minimum of 2 USBs, regardless of what NUC I use. One for the internal I/O board, one for the external panel, and so if I have, if for example someone was to blow up the internal panel, i.e. me, it only takes out this chip and that's easy to replace. Yeah, I like that idea. So we'll we'll just put a singular connector, and what I'll do, what was that Molex connector that had, it's DuPont spacing but it had locking tabs? They use it in in CD drives. I can't remember what that is now. 9004 for that connector. So let's put that in place, save, and what we'll do is we'll make this symbol. They do quite small chips then, don't they? Cool. What is it? What's amber? All the P ambers. Chapter 5 and Chapter 6. Okay, there's a lot of reading that I'll have to do on this chip, but I want to just put in a symbol at the moment. So let's go to the... Let's go and make a new symbol. Where do we put it? So USB 1. USB connector. Okay, we don't want connector, we want interface really. Actually, before we do that, schematic editor. It's a USB hub. Yes, there is, but that's a 3.0, 2.0. Is that my port there? That's a SOP 28, so that's... DP2 is 9. Oh. Wait, hold on a second. What is the so DP1 and DP minus? No, those are different pinouts. But what is the Phi 1.1? S. Is that a common part or is that just something? Yes, it is. That's a super common part then. Awesome. So let's put one of those on there. Saves us doing it whole thing. What is there any? Is there any recommended layout for it? That doesn't seem to be. It just says connect stuff. Right, I'm going to be right back. I'm going to just sort myself out a couple of things and we'll be back in about 5-ish minutes, I think. Right. Ooh, that looks like it. That does look like it. I'll give you that. But what's the what's the connector of it called? Because that seems like it's the male end. Yeah, I remember I think it's a Molex part. I just can't remember what it's called. Molex latching 4-pin 0.1 inch connector. Oh, that's close. Is that the one? No, I don't think it is. What is it? No, Molex SL. Maybe it's an SL connector. It's very similar to that, but we just want the locking version. Yeah, there we go. That's the one I was thinking of. Because the USB boards I've been using, they use this connector, which makes sense. It's a nice latching connector. Although it's not this complicated. It's like a more simplified version of it. So SL connector, or even connector core. Yeah, it's definitely that kind of style, but it's not. Yeah, that's the one. Yeah, SL. God, you've got to hand it to Molex. They give you really catchy names like 50-57-9404. Rolls off the tongue. So it mates to SL housing. Oh, good lord. I'm not reading it out again. You know what? I'm spending more time than I think is worth, and plus, maybe it's already in KiCad. So, Molex, connector Molex, clickmate. Oh, it is. Yes, we don't have to model it. Oh, I love that. So these are all vertical. You do get horizontal ones, but actually, wait, no, these are all vertical. Or is it something where like the? No, okay, it's just weird KiCad things. Oh well. We've got our connector, so I'm pretty certain then. Right, so let's get our D's over here. You know what, I could have the... So I was thinking a minute ago I could use that extra USB port to either add a fourth port on the back of the cab. No reason why I couldn't do that. Or I could connect the I/O board to that, but I'm not going to connect the I/O board because I would like the back panel to be able to be removed. Yeah, but if I do that though, if I remove the back panel, I'm not going to have the DC jack. I might want to try. Let's not tie it together if we don't have to. Let's do that. Because that way we can just modify it to suit. I'll just say that these for the moment are unconnected. Although we could just put those onto some pads for testing. I never put this camera back in the right place, did I? That should be better. Right, I don't think I need any of those. I need a thing for the thing. Thing for the thing. SL. So we need a 12 megahertz oscillator. 3 volt free power. Oh. Do we need to power it for 3 volt free? Ah, we don't have to. Excellent. So that is on pin 20. So I should probably do that. And then data plus, data minus. That is how the USB pinout is, isn't it? USB pinout. It's data minus, then data plus. That's irritating. I don't like that. Let's do it like this. You know what? I got a better idea. Let's wire that. We'll just put that down here, delete that wire, go up and across. There we go. Right, ground, I'm going to assume this gets connected straight to ground. Cool. Let's do that. A bit annoying, but it'll work. Right, 17 and 19. So 17 and 19. So bus power sense. This pin identifies the primary power source of the hub. High level indicates the hub is self-powered and has enough strength to support high power devices on its downstream ports. Otherwise, it is bus powered and each downstream ports are presumed to supply 100 milliamps of power. Right. So that means if it's So if we had an external, well, a power supply that went into this board, we would set this pin so that it knows when it's doing the USB configuration, the what do they call it? Enumeration, I think it is. That way it would know that it could supply several, like 500 milliamps per port, but otherwise it would tell each device you can only use 100 milliamps a port. So we need to set that to bus powered, so we need to put that to ground. So let's do that with a simple jumper like that. Right, OVC 26, OVCJ, overcurrent sense, active load from external current monitoring indicating overprotection for the global overcurrent protection. So that sounds like that we tie that to high. Okay, so these are all 5 volt tolerant, so what I'll do is it's a USB 5V. I don't like how close that connector is. We'll move that in a moment. Go from there to there, copy this. So overcurrent needs to be shorted to high because we are not going to use that. In fact, now we've done that, we can probably just do that. Let's get rid of that ugly wire. I suppose as well we could flip this around so it makes a bit more sense. Like, no, actually we can't. We'll just do that. Cool. Right, X reset J. I have a feeling I know what this is, but external reset for an old application should be pull up to 3.3. So we need to put a pull-up resistor from that. Let's put a 10k resistor on that then. R small, please. Put that to there, and then we'll move this connector again. The value of this we'll just put as 10k, probably more than enough. We need to put that to, we'll put a USB 3 volt. And then we'll put that down there. Right. So then we can put that to USB reset. Hello Super Jimtendo, thank you for joining us even if briefly. Nice to see you popped along. Appreciate that this kind of work is not everyone's cup of tea, but I enjoy it. I don't know why, it's kind of masochistic in a way. Cool. Right, what's VBus M? Upstream power monitor. High level indicates that the host is powered up, the hub should function normally. Low level indicates power down, should be in power down state. Right. We'll just connect that. Can we connect that into... Okay, we'll just connect it into USB 5 volts. Cool. VDD 33 and 1.8. I think they're just power outputs. 2.7 connectivity. Alright, so we need another resistor. What's that? 2.7k. And that connects to Rext. I'm guessing they mean VCC, they mean, well, in my case, they mean the USB VDD. VDD? I mean VBus. So that should be that. No connection, no connection, no connection. A 10 microfarad decoupling capacitor is required, so let's get C small. What did it say this needs to go? This needs to go on VREG 18. Am I blind? I can't see 26. Oh, wait, what? Oh, it's only on the LQFP version. So we'll keep that around just in case. Let's get a capacitor, SMD. We'll go 0802. 0805, sorry, and that was 10 UF, although that might have to be bigger anyway. What else do we have? VDD 33F, so we need to put, that's at 21. VDD3 is, right, this was the SOP version. What's the SOP version pin out for this? And we still need a crystal oscillator too. Right, I would need to do some research to know what kind of capacitors to put on that. I just know I would need some. Because 10 UF would be killer for this. In fact, what am I doing? Let's do that and get rid of those. I'm building an I/O panel, and here I am adding a USB hub. It's for the future, it'll make it easier, he lied. I mean, I do need a USB hub anyway, so if I'm going to put it anywhere, then I suppose on the back panel would make the most sense. Cool, alright, that's that. What's 25? Pin 25. This is an active low output drain signal for controlling power to downstream devices. So do I need to care about this? Oh, I see. So that's if you wanted to prevent inrush, you would connect that to transistors so that it only enables the power to the USB ports when it's turned on. Okay, we're not using that then, so we'll just leave that disconnected if we can. Drive. I'm guessing it stands for. LED control for during power reset uses charging hub enable. If tied to high, the battery charging function will be enabled. Otherwise, it is a normal hub, and this pin functions as an LED driving control pin. Right. Okay. So we don't need that. LED 1. Port 1 is connected to an indicator, and LED 2 is during high reset. I'd have to see what those are being used for. I'm not sure. There's 2 LED control pins. So, and then test ESDA 27. Output test mode. Active low open drain signal with internal pull-up resistor. When tied low during power, the check will be set in test mode. Distance for test tree only. For okay, so at the moment, no connection. But what we'll probably do is add a pad. Yeah, let's put on the test pad. Test point. Oops. And because it might be connected to an EEPROM in future, depending what I need. Let's go. Test point. I don't want, I just want to make some pads. Probably do that, yeah. So let's put 2. Right. So we just need to put some power up here, so 13 and 12. Overby is left as no connect for new design, or connectivity will be backward compatible. We'll just disconnect that then. And then 12, no connect. Cool. There's our hub. We'll probably put 2 capacitors. I'm going to do 22 PF down here for now. I know that's going to be wrong, but we'll have to see what that is. Save in case it decides to crash on us. Upload. Okay, no worries. I'll add those later. Oh, they're tiny. Look at them. They're so tiny. Right. So that's our USB hub, and that would make the most sense to connect it up to these, like put these nearby on the back around here somewhere, but I just realised I'm going to have loads of pins everywhere, so it's going to be kind of annoying to put S&D parts around here. But that's fine. So we've condensed 3 USB ports down into one. We've decided that we're going to use the multi-IO connector as our option connector, whether we want video in, audio in, or anything like that. We've got a HD audio connector here, which takes the audio in from here and the audio out to the cab, off the cab. There's no point me adding it to over here because I've only got like a few pins and I need them for switching signals. Which reminds me, so this is going to be grounded. But what I need is amp enable. So amp N. And I'll probably want IO enable. And no, I don't really think I need anything else because the PC itself is going to be, nothing's going to turn it on except for you pressing the button at the back of the cab. But here's a question: if I have the thing at the back, now my current one has a power button round about the bottom left corner of the NUC, so I could just make a little extension of that pushes on that button. But if I use the later NUC, they move the power button to the front of the NUC, which means I can't use that anymore, or at least I'd have to use some kind of levering system to press it. Option 2 is decase the NUC, put it onto the same plane, like a same support structure here that supports the IO board, supports the PC, and mounts them into this inside of the cab, and then use the front panel header that's available on most NUCs. I like the case of the NUC, but it kind of doesn't make sense to keep it on, does it? Because why not? We've taken everything else apart in this stream. Right, let's open up my NUC because I like taking stuff apart on streams apparently. It would if I could get the back off. Right, so we've got the inside of the NUC. So I'm looking at this and thinking to myself, if I decase this, took the circuit board out, put it into the CAD software, which actually I can Intel supply 3D files for the NUCs, and I think they give you the bare boards as well, so bare board model, so I would use that probably. Well, this is the thing, Mumbo, I think it might be in this case, because let's think about it. The NUC is entirely going to be inside of a case, it's going to be closed up most of the time. Do I have my smaller screwdriver? Yes, I do. And if I just take this out briefly, because as well, like, decasing it means if I needed to get access to the internal SSD, I only have to take off the back panel rather than unmounting all of the NUC as well. So let's take the NUC out. So like so this is the NUC PCB, like a little tiny, was it 4" by 4" board? Probably way off. Right, it's almost dead on 102 mil. Yeah. give or take 4" by 4" PCB. So if we were to imagine this in the back of the cabinet, your speaker's up here. You've got a frame to mount the PCB onto, and then what you'll see if you take off the back of the cab is that. I personally don't see. Here's the thing: I personally don't mind the idea of having, like, decasing it so I can have a front panel connector. I mean, I would like a cover on the inside, but then it makes it easier to mount because this is lighter than the whole case. Downside: this has the Wi-Fi antennas on the inside that I would have to stick onto the inside of the cabinet if I wanted Wi-Fi. But then, do I need Wi-Fi on this? I mean, the only time I'm going to be connecting anything to it would be, well, I suppose if I was running PC data or something like that, but then I'd probably use, like, the Ethernet, and I don't need Ethernet, so yeah, that seems like a better idea. And I could just get one with USB header on it, the 2-pin header, and then just have one going off to the back panel and one going off to the I/O board. So I'm not even using a Type A connector, I'm just basically using the board as it was. And then I've got access to the 2-pin Molex header, microfit, is it microfit or minifit junior connector, so I don't need to worry about having a DC barrel. And then that's 2 pins that can come off there. And I got front panel, so then I can relocate the front panel. I like that idea a lot more. And they kind of do and don't, Mumbo. I mean, what I mean by that is, like, most of the time they still have their shielding, but you know, as you can see, like in, funny enough, my own video, let's just skip to where you can see the case. You know, you got things like, there's a good example. So you could have either the steel cased version or this black and blue one. So it's a dumb reason to want a case, but that was one of the reasons I kind of wanted one. Yeah, no, one's from like, well, I think it's like early 90s they started having to do it for EMI. But yeah, earlier ones definitely didn't. But yeah, so you know that moment when you have a dumb idea, like a really dumb idea? What if we 3D printed a case for this NUC to look like the 573 on the inside of the cab? Completely no reason to do that, but what if we did that? Well, the funny thing is, Mumbo, I kind of already started that. Let me see if I can bring up a let's see if I can bring up something very quickly. Yeah, there we go. First of all, I like the fact that macOS has a built-in step file viewer. I already have modelled the entire front panel in Fusion 360. So we scale that down to fit the I/O panel of the NUC, print it in blue, and then have a black case that goes around it. I think that would look pretty sexy. I shouldn't have seen this. I shouldn't have thought of that now. Right. That's a good idea. I like that. So let's decase the NUC. We'll put it in a 573 case to make it look pretty. And then we will... And then for this, then all that means we need to do... We only need to have one USB connector, one connector for the audio, and both of those no longer, we don't need to use this SL connector. We can just change that to be a regular Molex header now. Not Molex, pin header, because we're no longer using we're no longer going to be using because there was a custom cable that connect to it, but if we're going to be designing our own board and everything, we might as well go standard cables. So then let's just put, we'll just put IO and amp enable over here. We'll just deconnect these, put those over here, because when you connect either the serializer or an external input, whatever, this would be enabling these anyway. We'll feed out 12 volts to the thing. We might have a very small 5 volt chip, like a 78L05, something like that. In fact, we'll add that 78L05, which is only enabled. Oh, we need. So we've got 1, 2, 3 grounds. I suppose we'll use IO enable for powering the external thing. So let's get a 78L05. Oh, it's only 100 milliamps. Oh, what's the AMS chip? AMS 1117. 1 amp positive fixed output regulator. Right, let's put that on there. We'll put on decoupling capacitors later. I mean, we're already going over spec. Right. So all of these VUSBs are now going to be 5 volt USB. This connector is going to take the 12 volt input and power out to the output. It's only going to have a small AMS regulator on the inside of it, just so that if there's something really basic, it's going to modify that. Sorry, it's going to power that. If you need more, you've got two 12 volt pins there, so you can do your own regulation. Or if you're powering a stand device, you'll just use part of the power from the 150 watt connector. The IO enable will also be the power supply enable for this, which actually it would make sense to use one that has a switch. Is this? These are just, there's no on off, is there? No. Okay, so power regulator. So is there one that does 5 volt and has fixed output 3 volt? Okay, so that's not quite what I wanted. But that's kind of what we want. We want one that we can switch the power out on and off of, so that it only powers up the external. It only powers up the things. I suppose actually we could just use some MOSFETs, but then I'd rather. Yeah, we could just put a MOSFET on the input of the 12 volt, so that it only turns on the 12 volt output, and therefore the 5 volt output, if you've got IO enabled. Yeah, let's do that. So I'll just put a note in there to do that. So I can't remember what the power. Let's get that. I can't remember what the max current rating of this is, but it's not a lot. So even if this only does like 500 milliamps per pin or something stupid like that, you know, you've got enough for basic stuff. I mean, I can't see any reason why you'd need more. Cool. So then really all I'd want to do, we'd still need a power connector for that, but I think I have a solution, and it is Molex KK. Okay, so let's do 0104. And what we'll do is we'll just directly connect this up. I'll make it look pretty later. We'll use the Molex KK connector, because I believe that can do a good amount of current. Molex KK will do 254. We need 4 pin. Because yeah, what's the Molex KK? I need connector. Is that what I want? Oh, that's the KK plus. Not quite what I had in mind, but it would work. Right. 4 position, 2.54. That's not the one I want. Did that seriously just... yeah, it did, didn't it? Cool. So that's the mechanical specifications. What's the electrical specifications? Okay, let's just click on that. Manufacturer part number. 4 amps, so 1 amp per pin. That's not a lot, really. Like, when you consider it all. Like, there's probably as much copper going into it. I suppose the other thing I could just do is just put a big ass connector on there, or several, because whatever controls the power to this PCB. I suppose this could be a kind of a slight distribution board. So it sends power straight off to the NUC. How big is it? Molex mini fit. I don't think it would fit depth-wise. Let's just quickly see, and then we'll wrap it up because I do need to get other stuff done. Molex Mini Fit Junior, or was it? No, it's Molex Micro Fit. I think it is. Yeah, Molex Micro Fit. Let's get a 2-pin connector. Stop downloading stuff. Just open up the PDF. Okay, well that's not quite the connector that I was expecting, but it's that kind of style. So this doesn't have the electrical details on it. It just has the mounting details. Oh yeah, it does have it. Oh, is this oh, this is SMD. Interesting. Okay, close you. I don't know if I want SMD. But let's just see. Two positions, please. Or do I do 4 position? I mean, I don't particularly care whether or not I have what connector goes onto the base. So I don't care particularly what connector goes onto this distribution PCB or whatever. I just care that it can deal with the current. It's done it again. Mechanical dimensions, yes. Okay, so this doesn't have the specifications, the electrical specifications, which I need. Get rid of you, close you, open up. I want the 2x4 though, I think. And I want a straight header if I can, please, sir. Straight, please. Whoops, I clicked the wrong button there, didn't I? Yep. Apply filters. Cool. There we go, that's the one I would like. £2.69 per connector. No, that's not through hole. This supports 8.5 amps, which is more that's more than the PD40 connector is supposed to support, so that's good enough for me. It's overkill anywhere in this board, probably massively so, but it makes me feel happy. So Molex Microfit, no, Microfit's big one. I need micro. Okay, Mini Fit is the big one, and then you got Nano Fit. So let's go Molex Microfit 2x2. We'll do it like this. And that would allow us to put that on the back side. Oh, it's a shame. We could have put it right there. I mean, we can still put it off down here or something like that, but we'd have to play around with it a bit more. Or we just put it to the side, you know. It's like sensible people would. I think we kind of got there. We kind of know what height we want now. We know it's all going to fit in there. I don't know quite the depth is going to work, but I have to clear 6mm of MDF anyway. And then the only irritating part of this whole project now is the fact that I still need a distribution PCB. But that's fine. I could actually potentially integrate that into the amplifier because it kind of needs to know when it switches on anyway. So I think what we'll do is, now I've got that base design down, I'm gonna go away, clean it up, and what I'll do is I'll figure out form like packaging and go from there. But that gives me the base, roughly the base design, so I can work from that. And then what we'll do is we'll come back in a different point and we'll do a stream on doing the amplifier, because I already know the design of the amplifier. I just need to actually design the PCB to fit in there. Yeah, I like that idea. Let's do that. And I'm not sure when we'll do the next stream, but I'll probably tweet about it and put it onto the usual places. So if you're not already subscribed, do so, because I'll make sure to put that onto YouTube again. Because this is all to do with the same series, so I'll probably do this after I've put out the next episode. And yeah, we'll go from there. I know you're subscribed, Mambo, but you never know who's watching this. Right, but that's going to be it, I think. I'm going to, like I said, save this, go and finish up off stream, just get a design, and then next stream I'll just briefly cover what I've done. But yeah, that's going to be it, I think, for today. Shame, because usually on Twitch you would do like a raid of someone else, but I don't feel like... Well, I know you can't do that on YouTube, and even then I don't really know who I'd be raiding anyway. But yeah, thank you for watching, and make sure you catch the next one whenever we do that. Bye. How do I end this now? This is a really bad ending.